If the relative atomic mass of natural copper is 3.54, calculate the proportions of the isotopes. Copper 6529, atomic number of 29, and copper 63 having atomic number of 29 in the metal. Now, we know that isotopy explains to us the idea behind one element having the same atomic number but different mass numbers. So here we have copper. We have copper 65 and copper 63. The isotopy of the isotope of this copper is what we have here. Now, we have to calculate the proportions, that's in percentage, the percentages at which this copper exists in the metal, copper 65 and copper 69. The percentages at which they all exist in the same metal, in the metal. Now, let's have this. What we're going to do is we'll look for the differences, the difference between the mass number, the relative atomic number, and the mass number of each of this copper. So for 65, this 29, we'll have the first one. Now we're going to have 65 minus 63.54. That's its abundance. So we have 65 minus 63.54. We'll have 1.46. The next one for copper 63, we have, now we cannot say 63 minus this, because if you observe, this is closer to this. So we'll have this, the relative atomic mass, 63.54 minus 63. Because if you do the reverse, you have a negative number. So we have 63.54 minus 63. Then we have 0.554. So what we'll do next is we'll check, we'll look for the total ratio. Well, let's have it, the ratio of the isotopes equals to is to 0.54. 1.46 is to 0.54. So we can have total ratio equals 1.46 plus 0.54. we have 2. Now, if we have gotten this, the next thing to do is to look for their proportions in percentage. Now, whenever you're calculating for 65, copper 65, this is the proportion you are going to use. You're going to use this ratio. Now, the reason is because if you check this, what do you call it? 63 is closer to the relative mass compared to 65. So if I'm calculating percentage for or proportions, so we have for 65, copper 65, we'll have, what we're going to have is this proportion. Instead of doing this, we'll have this. We'll have 0.54 over 2 times 100. We'll have 0.54 dividing by 2 times 100. We have 27%. The next one, we have for copper 63. We'll have, so whenever I'm calculating for this copper 63, instead of using this value, I'm going to use this one. So I'll use 1.46 over 2 times 100 over 1. So when you divide, you have 1.46 divided by 2 give us 0.73. Okay, let's just multiply 0.73 times 100 will give you 73%. So these are the different proportions at which this copper exists in the atom, in the metal. Thank you for watching. Do not forget to like, to share, and to subscribe.